Hey guys, super excited to be with you, and now we are starting sets. A very important topic but a very simple one as well. In today's lecture, we will learn about the introduction of sets, types of sets, subsets and supersets. What is proper subset and proper superset? This is what we are going to learn, and we will do the basics today. We will cover the NCERT questions as well, and we'll understand why this topic is important, if at all it is important, right? By the way, it is. So let's move ahead and let's start. So in next around 45 minutes, you will have mastered sets. After this class, you will not be required to go through your NCERT book or any other book. This should be good enough for you. Just do the problems and you're sorted, done, right? So let's begin. So we are talking about sets, relations and functions as a whole entity. We are starting with the sets today. But you know what? Why is this important? Sets, relations and functions, guys, is the beginning of calculus. From here, you build up the basics to enter the world of calculus as well. In general, a bit of higher order mathematics. And set theory basically is a way for us to understand the world around us. So the world around us is full of objects, right? Different types of objects, different types of animals, different types of people, different types of objects, different types of numbers. So to classify one type of thing, one type of objects is basically the study of sets. And how do we then find relations between them? So imagine we are talking about two different types of sets, two different types of objects. How are they related with each other? That is what is basically the study that we do in the chapter of relations. Functions, after that, is a way for us to understand the world in terms of input and output. You give input to a factory, you get some output, right? So this is what happens in our world. Something gets, you input something and you get some output. How do you mathematically understand that is the purpose of the chapter of functions. So in general, sets, relations and functions is basically a key for us to understand the world around us in the mathematical way. Chalo, let's begin. So today we are going to do introduction to sets, representation of sets, types of sets, subset and superset, proper subset and proper superset. And in the next class, we'll do Venn diagram and operations on the sets. 2 classes and this chapter will be over. Alright, there are certain topics which have been deleted by NCERT, by CBSE. So what is deleted? Power set, that is exercise 1.3, question number 5. Practical problems on union and intersection of two sets, that has also been deleted. Exercise 1.6, examples 31 to 34 and question 6, 7 in the miscellaneous exercises. This you can note it down, is the deleted portion. Alright, in my classes I will cover whatever I feel will be important for JEE, no matter what. So what is a set? So let's start with a simple story. The story of numbers is actually like the story of the evolution of our civilization. You know what happened? Long back, when in the prehistoric times, when us humans looked around, we saw certain things. 1 cow, 2 cow, 5 cow, 100 cows, goats, stones, trees. So everything we saw in the natural world around us was like 1, 2, 3, 4, 5. So we began with what we today call as natural numbers, right? So imagine this is what we started with, a set of natural numbers. Imagine in this box, let me put all the natural numbers, because that's what we started seeing as human beings when we came into this world, right? Imagine us seeing a dinosaur, 2 dinosaurs, oh my god, 5 dinosaurs, run away, right? By the way, dinosaurs were not there when the humans evolved. Joking. But after that, slowly we started comparing ourselves. We realized, you know what? This person has 5 goats. I don't have any. I have 5 cows. This person doesn't have any. So when you see something but you don't have it, it slowly led us to evolution of the concept of zero. I have 0 cows. I don't have something that person has, right? So from natural numbers, we added one more number to it, that is 0. because now we are comparing ourselves, right? So it happens in your life as well. You look at someone, this guy has this talent, I don't have this talent, I am zero. You should not do that, but that's how we start comparing ourselves, right? So then came the concept of whole numbers. So imagine this is the box where I keep all the whole numbers. Difference between these two is 0. Here there is a 0 extra, right? Now, as time moved ahead, we started doing business, right? And when you start doing business, then you get loss and you get profit as well. So imagine this guy, he had 5 goats and he thought, I'll go sell these goats in the market and I'll get, some cheese in return. Now what happened? The lion came, ate the goats. Now he had a loss. He imagined I would have had 5 kgs of cheese, but now I don't have that. So the perception is minus 5 kgs. So I should have had 5 kgs, but I don't have it. So the concept of negative numbers started emerging to help us understand the concept of loss as well. So now we are talking about additional set of numbers, which is what we call as integers. So we represent integers as z or I. So integers, so natural numbers has 1, 2, 3, 4. Whole numbers, one additional number 0. Now we are talking about negative numbers as well. For example, minus 1, minus 2, minus 3. Now times proceeded, our population grew, and suddenly what started happening? The families started getting divided. So there was this person who had 5 pieces of land. Now this person has 10 children. So everybody gets half the land, right? So, or this person had just 1 land and he had 5 children. So every child gets 1/5 the land. So suddenly we started realizing the need of the fractional numbers, the rational numbers, 3 by 4, 3 by 2, 1 by 2, 5 by 2, and so on. The things started getting divided. The division started happening. And hence, we realized the need of one more type of numbers, what we call as the rational numbers, right? Q, the rational numbers. Yes, And then we started doing construction. Imagine there came a time when we built the huge structures like the pyramids. To create the pyramids, we required the knowledge of trigonometry. So another different type of numbers started appearing, and those numbers were irrational numbers like pi. So here came another set of numbers which we call as irrational numbers, right? So and when we combine this entire world, this entire black screen, what we have? We have the set of real numbers. Bachcho, now do you realize with this, you naturally do this. Whenever you try to explain, so I'm telling you a story, and in telling a story, I naturally created these structures. One box, another thing in a bigger box, another thing in a bigger box. This is the concept of sets. That's how we naturally talk. That's how we naturally represent things in the world around us. And that's how the concept of sets evolved, right? This chapter is about a sophisticated study of how we do this, how we create operations around it, how do we, use the concept of the sets or this way of looking at the world to do some mathematical calculations as well, right? So this is the universal set is the real numbers, rational numbers set is the superset of integers, or integers is the subset of rational numbers. This is what we are going to study in this chapter, right? The numbers inside are nothing but the elements. These are elements inside the set. So this is how the sets are defined in general. See the definition. Sets are generally denoted by the capital letters. Say for example, the set of natural numbers. So let me say the set of natural numbers n. We represent the elements inside the set in the curly brackets. These are 1, 2, 3, 4 and so on, right? So we represent the set with the capital letter. The elements, what are these? These are called the elements inside the set. Okay? Whatever is there in the box, the collection of all these numbers is the set, each number is an element. Okay? Element in general is also represented by small letters, right? If we need to. Also remember that any element which is inside or which belongs to a set is represented as, for example, 1, the element 1 belongs to the set of natural numbers. So whenever you will see this, we will read this as belongs to. We will read this as belongs to. This is clear. Another thing is elements of this elements are not repeated in the set. So imagine, I'll take some example and we'll make it clear. But remember, elements are not repeated. We'll learn it with an example. Okay. Now there are two ways of representing sets, bacho. One is the roster form, that is curly brackets writing all the elements inside. And another thing is the set builder form, which is this. Set builder form is what? When rather than writing the elements, you write the rule set. For example, in this case, read it with me. It is, this curly brackets is a set. Let me give it a name. So let me give it a name V. So V is the set of all the vowels. So how do we read it? V is the set of all X, is the set of all X. This is called as such that. Read this as such that. So set of all X such that X is a vowel. This is the rule set. X is a vowel, right? So this is the set builder form. Set of all X such that X is a vowel. This is the set builder form. And this in the roster form will be, let's write all the vowels, which is A, E, I, O, U. Set builder form, roster form, right? Write all the elements in the curly brackets, it's the roster form. Clear? So this is as simple as that. This is how we represent sets, either by writing the rule set or by writing all the elements all together, right? Now let us see this in form of examples. Look at this. So what we have here, bacho, is write the following sets in the roster form. It says A, read it with me, A is set of all X such that X is an integer and X lies between -3 to 7. -3 and -7 are not included. Can you write it with me? So let's write it in the roster form, curly bracket. Let's write all the elements inside. So -3 -3 to 7, -3, 7. What are the integers in between? -2, -1, 0, 1, tuck till 6. Agree? So what are the integers in between? -2, -1, 0, 1, 2, 3, 4, 5, 6. Should I include -3 and 7? No, because there is no equal to sign here. Got it? So this is the set of all integers which lie between -3 and 7. Simple. B, set of all X such that X is a natural number less than 6. A natural number less than 6. Remember, natural numbers start from 1. So less than 6. What are they? 1. Because natural numbers are the numbers which we see around us. 1 cow, 2 cow, right? 1 goat, 2 goat. 1 stone, 2 stone, kind of. So it starts with 1, 2, 3, 4. We need less than 6. So 5. Stop. Because it does not say less than or equal to 6. So we will stop at less than 6. 5 is a natural number less than 6. We stop there. Okay. Now, D, X is a prime number which is a divisor of 60. What are the divisors of 60? 60 kya hota hai? What is 60? 60 is 6 into 10. 6 into 10, which is 2 into 3 into 2 into 5. These are the divisors, right? So 2, 3 and 5. What it wants? It wants a prime number which is divisor of 60. Which are the prime numbers in this? 2 is a prime number, 3 is a prime number, 5 is a prime number. So can I write this as the set as 2, 3 and 5. See, I took 2 only once. I took 2 only once because we saw when you represent a set, you take a element only once, right? Don't repeat it while writing the set. Similarly, the set of the letters in the word trigonometry. Again, write all the unique letters in the word trigonometry. Don't repeat the letters. Don't repeat the letters. So what are the letters? So what are the letters which are repeating first of all? T is repeating. I'll write T only once. R is repeating. I'll write R only once. Right? I is only once. G is only once. O is repeating. I'll write it only once. N, M, E, ठीक. So what will happen? T, R, right? I, G, O, and N. So T, R, I, G, O, N. O repeat हो गया. M again unique, right? E unique. E is also unique. Let me write it here. E is unique. And then T is repeating. R is, we have already written. Y is unique. So these are the letters in the word trigonometry. So the set of all the letters in the word trigonometry is this. So you will not repeat T 2 times. You will not repeat O 2 times, for example. This is clear. These are very, very basic concepts. Just flow through it. Keep it in your mind so that you don't have to repeat it again and again. After this class, I don't want you to go back to revise or read the theory again. Done with it, do the problems, move ahead. You don't have to come back to this chapter anytime after that. Alright, that's the purpose of today's class. Doing it with the depth, slowly, relaxed way. 45 minutes, done. You don't have to come back to it again, okay? Now, write the following sets in the set builder form. Now we are doing opposite. What did we do here? This was a set builder form. You wrote it in the roster form. Now, what do you have? You have the roster form. Identify what is the rule set, and then we'll write the rule set in the set builder form. 3, 6, 9, 12. What do you see? It's a multiple of 3, right? So what do we write? So can I write this as, it is a set of all the x such that x is a multiple of 3, right? 3 ones are 3, 3 2, 3 into 3, 3 into 4. So x is actually 3 times n, where n is a natural number, when n is a natural number, and when n is less than or equal to 4. Does that make sense, bachcho? Does that make sense? Set of all x such that x is a multiple of 3, 3n. N belongs to natural numbers, n is a natural number, n is less than equal to 4. Because when I write n less than equal to 4, it automatically means it is greater than or equal to 1. Because natural number starts from 1. Are you getting me? Right? Had I written n belongs to integers, remember z. When you represent z, this is the set of natural numbers, this is the set of integers, right? Had I written n belongs to z, then I would have been required to write this. N is less than equal to 4 but greater than equal to 1. So either you write like this or you write like this. It's your choice. If you're writing n belongs to natural numbers, less than equal to 4 is enough. If you're writing as belongs to integers, less than equal to 4 can mean you can go to negative numbers also, right? So in the case of integers, you'll have to say n is greater than equal to 1, less than equal to 4. Very important, because you can do mistake here. That's it. What is this, bachcho? Similarly, 2, 4, 8, 16, 32. Is it a multiple of 2? Or is it 2 raised to power 1, 2 raised power 2, 2 raised power 3? 2 raised power 1, 2 raised power 2, 2 raised power 3, 2 raised power 4, 2 raised power 5. So this is set of all x such that x belongs to 2 raised to power n. Let me use this format, the natural number ones. N belongs to natural numbers and n is less than equal to 5. Clear? Similarly, can you do this yourself? And what is this, bachcho? 2, 4, 6. What is this? These are multiple of 2. Can I write this as, I want you to do this exactly like the second one. This is set of all x such that, what is this? 2, 4, 6, multiple of 2. But there is no restriction on it. So what does it mean? So x is equal to 2n. N belongs to natural numbers. End of the story. I didn't put any restriction. There was a restriction here, there was a restriction, there was a restriction. Here, no restriction. Actually, later on we'll study these are finite sets. Number of elements inside the sets are finite. You can count the number of elements inside the set. Can you count the number of elements inside the set? No, infinite. It will keep on increasing. 2, 4, 6, 8, 10, 12 and so on and so forth, right? Okay, it will keep on increasing. So this is an infinite set. We'll study that as we go in. Go ahead, right? Clear all of you? Should I move ahead? Now, these are some of the notations that you will see and that we will use. We will use that we just saw: n, set of all natural numbers; z, set of all integers; q, set of all rational numbers. Please keep this in mind, right? R, set of all real numbers; z plus, set of all positive integers, which is 1, 2, 3, 4 and so on. Set of all positive integers means don't include 0. 0 is neither positive nor negative, right? So z plus means 1, 2, 3, 4, 5 positive integers, right? Now q plus, the set of all positive rational numbers, and similarly r plus, set of all positive real numbers. So you can note it down with me. The things which you find important, you can keep noting down in your notebooks with my class. Alright, should I move ahead? Chalo. So these are important notations. Now, can you tell me the set builder form of this set? Look at the options carefully. The numbers are 1 by 2, 2 by 3, 3 by 4, 4 by 5. This is the roster form. You have to identify the set builder form. Which of these relations, rules will create this? Pretty simple. See carefully. What will happen? 1 more than the numerator, 2 1 more than the numerator, 3 1 more than the numerator, 4 upon 1 more than the numerator, right? So do you see the format is n upon n plus 1, the format is n upon n plus 1, n upon n plus 1, and the values of n which can enter inside is, here the value of n is 1, so n can be 1, it can be 2, it can be 3, it can be 4. So I can write that as n lies between 1 say 4, where n is an integer and it is a set of all n upon n plus 1, set of all n upon n plus 1. Correct? This satisfies it. The answer is B. Got it? Clear all of you? So let's move ahead. So see here, n belongs to z. Imagine if it was written n belongs to natural numbers. Then what condition you would have written? You would have simply written n is less than equal to 4. That was sufficient. Simply writing this would have been sufficient if n belongs to natural numbers. But since we wrote n belongs to integer, hence we had to substantiate that with n greater than equal to 1. Right? Cool? So let's move ahead. Now what is an empty set? What is an empty set? A set which does not contain any element is a empty set. Nothing is there. For example, set of all the people whose height is more than 500 meters. Nothing. There is nobody like that in the world, right? Set of all the students who have no aspiration in life in this classroom, in my class. I hope it is null set, right? I hope you have great ambitions, great aspirations for yourself, right? So, set of all the natural numbers which are negative. There is no natural number which is negative. Null set, right? So what is null set? A set which does not contain any element itself. So the set with no elements or null elements in it is called an empty set. It is denoted either by the curly brackets with nothing inside, or it can also be represented with phi, right? So it means null set. Remember, this is a set. This is what we call as a null set. We also call it phi, but remember, it is a set. Remember, this is a set. Null set is a set. I'll talk about it as we go ahead more, right? So look at some of the examples. Look at this. Set of all x is that x square plus 1 equal to 0. X belongs to real numbers. Is there any real number such that x square plus 1 is equal to 0? Any? Is there any? What does it mean? Implies null set. There is no x which can make x square plus 1 equal to 0. Right? There is no real number. I'm not talking about complex numbers. There is no real number x which can make x square plus 1 equal to 0. Hence, the outcome is nothing, null set. Now, x, set of all x such that 2x minus 3 equal to 0. 2x minus 3 equal to 0 will give you x is equal to 3 by 2. But x is given to be an integer. So, set of all those x which are integer and also satisfy this, nothing, because what satisfies this is a fraction, is a rational number. It is not an integer. So the outcome is nothing. There is no x which is integer as well as which satisfies this. Got it? So these are the examples of the null set. Now, look at this and tell me which of these are the examples of nothing, null set. Which of these are the examples of null set? Look at this carefully. Set of odd natural numbers divisible by 2. Is there any odd number which is divisible by 2? What is the definition of odd numbers? Other than the even numbers, right? So 1, 3, 5, 7, none of the odd numbers is divisible by 2. So the set of odd numbers which are divisible by 2 is definitely phi, null set. There is nothing in this. You can also represent this with empty curly brackets, right? Empty curly brackets. Now, set of even prime numbers. Even prime numbers. Is there any even prime number? A prime number which is also even. What are the prime numbers? 2, 3, 5. Oh yes, there is one. There is one. So the set of even prime numbers will give you a single element 2. Single element 2, yes. So this is definitely not phi. This is not a null set because there is one prime number 2 which is also even. A prime number which is even is 2. So it is not a null set. The answer is, the roster form of that is the element 2 inside the curly brackets. Now set of all x such that x is a natural number, x should be less than 5 and should be greater than 7. Alien hai kya? there is nothing which can be less than 5 and at the same time greater than 7 as well. ठीक है? So it's some god creature. It's not possible. The answer is phi, right? It's like being in two places at the same time. So you should be in Tokyo, you should also be in San Francisco at the same time. It looks like that, sounds like that. Not possible, right? Set of all y such that y is a point common to any two parallel lines. Two parallel lines. Is there any point which can be common between the two? If there was a point common between two lines, then the two lines would have been intersecting lines. In the intersecting lines, the point of intersection is the common point, right? So in these two lines, this is the common point. But if the lines are parallel, there is no common point. So yes, So is there any common point? No, phi. So why is the point common between two parallel lines? No, nothing. There is none possible. So the answer is these three are phi. The B1 is an element 2 in the set. Okay? Cool, awesome. Can you tell me this? Very interesting. Can you tell me this? Phi is a null set. It's not phi. See, read this. Phi is a null set. Correct? Correct? Agree? So imagine, so in your mind, imagine a null set as an empty box. Khali dabba, an empty box. So what is a null set? An empty box. Now, what have you done? You have taken another box. The curly bracket means a box. A box. You have put in an empty box inside. You have put in an empty box inside. Right? So is this box empty anymore? No. There is something inside. Right? So is this a null set? No, it is not a null set anymore. Got it? Are you getting what I'm trying to say? So this is a box. Imagine this is a box. Inside the box, you have put an empty box. Right? So when you have put in an empty box inside a box, is this box empty anymore? No, it is not. There is a box inside. Got it? It's a very important concept. It's a very important concept. You will do a lot of mistakes in this. So remember, phi is a null set, or in your mind read this as empty box. So phi is an empty box. You put this empty box inside something, that thing is no more empty. This box will remain empty. Got it? Cool? So very good. Awesome. Now, a set which has, so by the way, what are we doing till now? We are doing types of sets. Just for your summary, what are we doing? We are doing types of sets. So what are the type of sets that we have done till now? We have done empty set, right? Now we are doing the singleton set. Singleton set is the set in which there is only one element. Can you tell me an example of this from the real world? Think about it. Give me an example in the real world. Don't give me a numerical example. An example that you see around you. The set of all the prime ministers of India who were there on the post in 2022. How many prime ministers were there in the India? One, right? The set of the prime ministers in India in 2022, one. The set of J rank 1 in 2022, 1. Rank 1 to 1 की आएगी ना, right? It will be only 1, right? Cool hai? Clear? So these are some examples of singleton set where the outcome is only one element inside the set, right? For example, this is a singleton set. Set of even prime numbers, singleton set. This is a numerical example of it. Got it? Cool. So look at some more examples. A set containing single element is called the singleton set. If you were to look at some of the examples, see, this is a singleton set with an element 1 in it, singleton set with element 0 in it. This is also a singleton set with one empty box inside it, one element inside it, right? This is, look at this very carefully. Inside this, is this a singleton set? Is this a singleton set? Yes, it is. See, once you put something in the curly bracket, it becomes one box, it becomes one entity, right? So what is there inside this bigger box? So imagine this is the bigger box. Inside this bigger box, there is one box. There is one box. I don't care what is there inside that box. But how many elements are there inside? How many boxes are there inside this bigger box? One, right? So this is also a singleton set. This is also a singleton set. Remember, when you put something in the curly bracket, inside a set it becomes one single entity, one element. Got it? Clear? So this is very important point. This is a very important point. Okay, you can note it down in your notebooks. So this confusing for students, and this is also very confusing for most of the students. This should be very clear to you, so you can note it down very carefully in your notebook, right? And when you revise sets, just revise these 1 or 2 points. Cool? So let's move ahead. Now finite set. So in learning types of sets, we have come down to the finite set. What we have done till now: null set, singleton set, finite set. Very simple. When the number of elements are finite, most of the sets we have been seeing till now are the finite sets, right? Now, for example, the set of all the vowels, for example, that's the example that we started with, right? So set of all vowels V, A, E, I, O, U. How many elements are there? 1, 2, 3, 4, 5. 5 vowels, finite. Alright. Now listen to this carefully. Number of elements in a finite set is also called the order or the cardinality of a set. Order or the cardinality of a set, right? So let me write it in. So this is very important. So cardinality of a set A, we also call it order of the set, right? We represent this as number of elements in the set A. Simple, right? So what is the cardinality of this? How many elements are in this? What will you say? So number of elements in the set V is 5. The cardinality of this set is 5. The order of this set is 5. Simple. Clear? Now, so this is the finite set with finite number of elements, but you can also have infinite sets. For example, can you give me an example? The set of all natural numbers, for example. So set of all natural numbers are 1, 2, 3, 4, 5, and it will keep on going till I don't know when, right? That is infinite number of natural numbers are there. So this is an infinite set. Set of all integers, infinite set, right? Set of all whole numbers, infinite set. Got it? All these are infinite sets. Now let's do an example. So this is your NCERT exercise 1.2 question number 2, just to give you a sense of the kind of questions which come. Okay? Look at this. Which of the following sets are finite or infinite? Very simple. That you can do quickly, verbally. Just write finite, infinite. Set of all, the set of months of a year, finite, 12. So this is finite, right? 1, 2, 3, dot, dot, dot. Basically, this is set of all natural numbers. It will keep on going, infinite, right? 1, 2, 3 से लेके 100. The set of all natural numbers from 1 to 100 definitely is finite, obvious, right? The set of positive integers greater than 100. The set of positive integers greater than 100, what will they be? So greater than 100 is 101, 102, 103, dot, 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 infinite. So there can be infinite such numbers, right? The set of prime numbers less than 99. Prime numbers less than 99 is finite. So prime numbers from what? Starting from 2 to 99 are finite only, right? So this will be finite. So very simple. This, till now there is no exertion on brain. It is very simple chapter. Just do it. Now look at this. If this particular set is given to you, the question is, what is the cardinality, what is the order, or what, how many number of elements are there in this set? How many number of elements are there in this set? The set A is element 1, element 2, there is another element which is a box containing 3 and 4. So how many elements are there, bacho? This curly bracket is one single element for this set. So element 1, element number 2, element number 3. How many elements should be there? 3, exactly. So don't make this mistake. A lot of students do what? They do 1, 2, 3, 4. No. Once you have, put something in a box, it has become one single element for the bigger box in which it has been kept. Alright? So this is important concept. Equal sets. As the name suggests, equal sets are the sets in which not just the number of elements, but the elements are also same. Two sets containing exactly same elements are called the equal sets, right? And what we are learning types of sets. We have done null set, singleton set, finite set, infinite set. We are doing equal set, right? So all the elements should be equal. For example, let's take example here. So equal sets, see, a set A with elements 0, 1, 2 and a set B with elements 2, 1, 0. Order does not matter. Just simply look at the elements. Think of it as a box. So this box has 0, 1, 2. This box also has the same elements 0, 1 and 2. Don't get confused by the order in which the elements are written. It does not matter. Because you can shake the box, right? In the box you have put 0, 1 and 2. You can shake it. When you open it, they can appear in any order, does not matter. But the elements will remain the same, right? So these two are equal sets. A and B are equal. So we can say A is equal to B. A set is equal to B set. And C, 0, 1, 1, 2. I've told you, writing elements, the same element twice, it doesn't make any sense. Which are the unique elements inside C? 0, 1 and 2 only. Okay. This seeing 1, 1, 2 times, it doesn't make any sense. You are talking about the unique elements inside the this particular set. What will be? So the elements inside the set. Imagine this was a box. So the box में क्या होगा बच्चों? 0 होगा, 1 will be there and 2 will be there. In this box again 0, 1 and 2 will be there. All these are equal. So A equal to B equal to C is very important. So again I have purposely took this example so that you don't get confused. Got it? Clear? Now equivalent sets, it does not matter if the elements are same or not, but what matters in the case of equivalent sets is the number of elements should be same. That's it. For example, a set containing 1, 2, 3, how many elements are there? The number of elements, say this is A, this is the set A. So number of elements in the set A is 3. Dog, cat, parrot, say this is the set B. This is the set B. The number of elements in the set B is also 3. Now since number of elements in set A is equal to number of elements in set B, we call them equivalent sets, right? Just look at the number of elements, look at all the elements. They should be equal. Only number of elements should be equal in equivalent sets. Got it? This is clear to all of you? Overlapping sets, pretty simple. You can visualize it. For example, a set this and a set this. If there are elements common between these two, we will call them overlapping sets. For example, there is a set A. So let me write it in this white. Say in the set A, the elements are say A, B, C, D. In the set B, its elements are D, E, F, G. So if I write this in the roster form, you will say A has A, B, C, D and B has, you will say D, E, F, G. Is there an element common between the two? Yes, there is an element D which is common between the two. Then we will call these two sets as the overlapping sets. The definition is two sets are said to be overlapping if at least one element from set A is present in set B. So set A and set B should have at least one element common between the two. This exactly is the case where only one element is common. There can be more elements which can be common. ठीक है ना. तो ये तो बहुत ही, it's very very simple, it's super simple. At disjoint sets there is nothing common, fair enough, right? So this is one set, this is another set, there is nothing common between the two. This is set A, this is set B. If there is nothing common between the two, we call them disjoint sets, and we will study in the next class that the intersection of these two sets will be phi, null set. Intersection between A and B will be phi, that is null set. Clear? Alright, now let's see some of the kind of questions which come. Check, are the following pair of sets equal? Give reasons. So this is your NCERT problem, just to give you a flavor about the kind of problems which come from this portion. Read this. Are the following pair of sets equal? Give reasons. So there is a set A which has 2, 3, right? In the first one, A has 2, 3, elements 2 and 3. B, what is B? X square plus 5x plus 6. Can you factorize it very quickly? So x square plus 5x plus 6 equal to 0. This is x plus 2 into x plus 3 equal to 0. Agree? 6 is 2 into 3, 5 is 2 plus 3. You can factorize. The roots are minus 2 and minus 3. Right? So set B is set of all x, so that x is a solution of this. If x is a solution of this, right, it implies B is what? The solution is minus 2 and minus 3. Is there anything common between the two? Nothing. So are these two sets equal? No, these two sets are not equal. So this is no. Look at the second one. A is a set, X is a letter in the word follow. In the word follow. So can you write down this in the roster form? Remember, don't repeat the letters. Don't repeat the letters, right? F will come once, O will come once, L will come once, and W will come once. Similarly, in the set B, Y is a letter in the word wolf. W once, O once, L once, F once. Are these two equal? Yes. W, W, O, O, L, L, F, F. So yes, the letters or the elements in both the sets are same. So these two A and B are same. In this case, A is equal to B. So such very simple questions come from this particular portion. Clear? I think this is a very simple chapter, and I want you to take this lecture as, you know, a relaxed session to understand whatever there is to be understood and be done with it, so that you don't have to come back to it. Your basics are super clear. Even if the question comes in J, you are sorted with it. Okay? Alright, cool. Now let's come to the last concept, which is subset. So what is a subset? Remember, we started this class as that we have a set of natural numbers, which is a subset of the set of whole numbers. Only number different between the two is the number 0, which is a subset of the set of integers, which is a subset of the set of the rational numbers. Remember? So this is nothing but the subset. What's its definition? When all the elements of set N are also the elements of set W, then N is called the subset of W. Simple definition. Read it. For two sets A and B, if every element of A is also an element of B, so all the elements of this set are also the elements of this outer set, then this inner set is a subset of the outer set. So all the natural numbers are also part of the set of all the whole numbers. Correct? All the whole numbers are also part of the set of all the integers. Correct? Right? So N, so how can I represent this? N is a subset of W, which is a subset of Z, which is a subset of Q. This notation, subset. If you read it from the other direction, you get the other definition, which is superset. Q is the superset of rational numbers, is the superset of integers, integers is the superset of whole numbers is the superset of natural numbers. Got it? Clear, all of you? So now you know what is a superset, what is a subset. Now this notation means that the set could be equal as well. It's like less than or equal to. A is a subset of B, then A can also be equal to B. In this case, right? The case where A is not equal to B or A is not allowed to be equal to B, we call them proper subset, right? So we represent it like this. In case two sets A and B are such that A is inside the B, but A is not allowed to be equal to B, right? We call such subsets as proper subsets. Proper. No equality can be there between them, right? Similarly, B is a proper superset of A. B cannot be equal to A in this particular case. So the only difference between subset and proper subset is when you say it's a subset only, then you are giving allowance to the sets to be equal to each other as well. Okay? When you say no, it's a proper subset, then you are saying, dude, this set is definitely inside the bigger set, it can't be equal to it in any case. Clear? So this is simple, this is clear. Now look at some of the examples here. So 1, 2, 3 is a subset of 1, 2, 3, 4, obvious, right? Because if you see it with this way as well, so the set 1, 2, 3, so this is a set, and there is a 4 also, which is this set. So this is the set B and this is the set A. So A is a subset of B. This is clear to all of you, right? Now this is very important point, bacho. So a lot of objectives can be created from this. Remember, every set is a subset of itself. Because I told you in the definition of subset, the sets can be equal as well. So when you say the subsets of set A, it also includes the set A. Remember this. So every set is a subset of itself. Note it down very carefully. Every set is a subset of itself. If there is a set A, if somebody asks you its subsets, A will be a subset of A itself also. The same set is the subset of itself. Okay. Phi is a subset of all the sets because nothing is there in everything. Right? So phi is a subset of all the sets. In case, third point, in case A is a subset of B, but B is also a subset of A, there is only one possibility, both are equal. Got it? So if A is a subset of B, if B is a subset of A, you can think of this like this. If I say X is less than or equal to Y, and I say Y is also less than or equal to X, what's the only possibility? X equal to Y is what is being said. X is a subset of Y, but Y is also a subset of X. Only possibility is both are equal. Alright? Because in the case of subset, there is an equality. Possibility of the equality between the two. So these three are very important, and these three leads us to creation of certain problems. For example, if there is a set A, A, B, and the third element 1, 2, 3 in the curly brackets. How many elements are there? 3. Element 1, element 2, element 3. Now, how will you write the subsets of A? So you can think of this as this. So elements are, one element is A, one element is B, another element is 1, 2, 3 wala box. These are 3 elements inside. So is set containing elements A and B subset of A? Yes. Is this set a subset of A? Yes, it is. Correct. Is 1, 2, 3 wala box and B, is that a subset of A? Yes, it is a subset of, remember this, see, this is, I am creating this set now. Is that a subset of the set A? Yes, it is. Right. Is phi a subset of A? Yes, phi is a subset of, it is, phi is subset of every set. Clear? This should be very clear to you. Alright. Now, let's come to the final universal set. Very simple. Which contains everything. Which contains everything is a universal set. This universe contains everything, every object, every collection of objects. That's a universal set. Right? For example, the example that we took here. Can you say Q is the universal set for all the sets? Yes. Or the real numbers is a universal set for all the possible numbers? Yes. We can take some examples to understand it as we go ahead. Right? Some of the notations that we will read in this chapter, many we already have. Universal set, B belongs to A does not belong to B, phi, union, intersection, we will read in the next class. A is a subset of B is a superset of A. So we have done all these notations, right? Union and intersection is something that we will do in the next class. Okay, but these are all the notations. Now, can you tell me, in terms of subsets, are these correct statements? Set containing the elements AB is a subset, is not a subset of the set containing BCA. Wrong, right? Because AB, both the elements are also included in this particular set. So A and B are also present here. So definitely this set is a subset of this set. So this is not correct, this statement. AE is a subset of, X is a vowel in the English alphabet, of course, because this set is nothing but A, E, I, O, U. Right? So AE is a subset of A, E, I, O, U, correct? 1, 2, 3 is a subset of 1, 3, 5. No, not all the elements of this are present in this. Hence, because there is an element 2 which is not present here, right? So is this thing entirely present inside this? No, because of this element 2. So this is not a subset of this, right? Not a subset. Definitely a subset. X is an even natural number less than 6. So what is an even natural number less than 6? Even natural number less than 6. 2 even numbers, 4. So 2 and 4 are the even natural numbers less than 6, not equal to 6. Now the second statement, set of all x such that x is a natural number which divides 36. So what divides 36? A natural numbers which divide 36 is 1, 2, 3, 4, 6, right? And what others? What others are there? 36. So is 2, 4 a subset of this? Yes, 2 and 4 is a subset of this. So this is also correct. Got it? Clear? Perfect. Awesome. Now write down all the subsets of the following sets. Can you write down their subsets? Remember, Well, when you're writing the subsets, remember a set is a subset of itself. Phi is a subset of every set. Don't forget that. For example, A, its subsets are the set itself and phi, right? So phi is a subset of everything. The set itself is the subset of itself. Got it? For example, this will give you a clearer picture. The subsets are set containing only element A, set containing only element B, the set itself, and phi is a subset of every set. Clear? Similarly, look at this. Phi is a subset of every set. The set containing element 1, set containing element 2, set containing element 3, set containing element 1, 2, set containing element 2, 3, set containing element 1, 3, and the set itself, that is 1, 2, 3. Typically students miss out on the set itself and the phi. Don't do that, right? Phi is a set. The only subset is itself, right? So the only subset of the set, remember phi is a set, phi is an empty box, right? What is its subset? The set itself, phi itself. Got it? So this completes, this should give you clarity of all the possible scenarios that can get created. Alright, I hope this is clear to all of you. Okay, now let's look at one example of the superset as well. So given sets, so what we have done till now, bacho, we have seen all types of sets. Finite set, infinite set, null set, singleton set, right? Subset, superset, proper subset, proper superset, universal set. This is all that we have done till now in today's class. Now, given the sets A and B and C, which of the following may be considered as a universal set for all the sets A, B, C? In simple words, the universal set should contain everything contained by A, everything contained by B, everything contained in C. If you put elements of A, B and C in a box, that box is the universal box, the universal set, right? So what will that be, bacho? So which of this set contains everything contained within this? 1, 3, 5. This definitely not. What does it not contain? It does not contain 8, not, right? It does not contain this one, 0, 1, 2, 3, 4, 5, 6, 7, 8. Which one is not contained in this? Think. But we're talking about a superset, right? Should it not be this? Because it contains everything that is contained in all the three sets. Yes. 1, 3, 5, 1, 3, 5. 2, 4, 6, 2, 4, 6. 0, 2, 4, 6, 8. 0, 2, 4, 6, 8. Everything is contained in this. So perfect. This is your universal set. Got it? Clear all of you? Now, cool. Now what I want you to do, I want you to practice some of the NCERT questions. I have given you some questions here which you can try on your own, but in general it's very simple. Go and attempt all the NCERT questions very fast. Some questions are here, you can attempt it on your own. Alright, and let's do a quick summary of what we have learned till now. In today's class we learned lots of things, but can you tell me in terms of giving the answer? Just for your summary, a set containing only one element is, what is this? Just keep saying. Singleton. A set that does not contain any element. So this is, keep writing. Singleton. A set that does not contain any element, null. Keep answering it. Set in which all the elements of B are contained in A. All the elements of B are contained in A. Subset. Set of all the elements or members of all related sets is the set of all the elements or members of all related sets, universal set. Everything, it is like everything, right? Universal. A dash is a well-defined collection of objects. What is a well-defined collection of objects? Set. Yes, simple. It's just a quick summary of what we have done in this chapter, just to end the session, right? And sets having a countable number of elements is finite. Finite set. If any set is endless from start to the end, if it is endless, infinite set. You call it infinite set. Two sets A and B having exactly the same elements is, two sets having exactly the same elements are, same number of elements nahi, same elements, equal. If the elements are same, sorry, if the number of elements are same, if their cardinal numbers are same, we call it equivalent sets, right? Cool. All right. Is this clear, all of you? Now, so this was all, bachcho. I'll end this session with, kahan gaya wo mera? Ah, yes, here it is. And yes, bachcho. So what I end every session with is y equal to x square. Have a beautiful smile on your faces. I will see you in the next class on the Venn diagram and the operation of sets, and after that we will enter the world of relations and the functions, right? And again, I will take the classes at a relaxed pace so that with me in 1 hour or 45 minutes, whatever time it is, once you do it, you don't have to refer to the book again. Just your notes will be sufficient for you to revise it. And then with time, we will do level up sessions where I will increase the level to JEE Mains and JEE Advanced as well. All right. See you in my next class. Bye-bye. Have fun and do join the Telegram group. The link will be there in the description and you will get assignments there. All right. Bye-bye.